Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. Saturn, the ring giant of the solar system. In the vast expanse of our solar system, a collection of planets orbits the Sun in a delicate gravitational dance. Among them, Saturn stands as one of the most iconic and recognizable worlds. Known for its spectacular system of rings, Saturn is the sixth planet from the Sun and the second largest in our planetary family. While Jupiter surpasses it in size and mass, Saturn has carved out a unique identity through its appearance, its complex system of moons, and its rich history of exploration. From the earliest observations with primitive telescopes to the high-resolution images sent back by modern spacecraft, Saturn has fascinated scientists and the public alike. It is a planet of extremes, a gas giant with an atmosphere dominated by hydrogen and helium, a world so light that it could theoretically float in water, and a celestial body whose environment is both hostile and beautiful. In the study of planetary science, Saturn serves as a laboratory for understanding not only gas giants, but also the processes that shaped our solar system. Saturn is classified as a gas giant, meaning it lacks a solid surface. Its diameter is approximately 120,536 kilometers at the equator, more than 9 times that of Earth. Despite its vast size, Saturn's mean density is only about 0.687 grams per cubic centimeter, making it the least dense of all the planets. This extremely low density is due to its composition, roughly 96% hydrogen and 3% helium, with trace amounts of methane, ammonia, and other gases. Its mass is about 95 times that of Earth, and its gravitational pull is roughly 1.07 times Earth's gravity at the cloud tops. Saturn rotates rapidly, completing one full rotation in about 10 hours and 33 minutes. This fast rotation causes a noticeable flattening at the poles, a phenomenon known as oblateness. The planet's axial tilt of 26.7 degrees gives it distinct seasons, much like Earth, although each season lasts more than 7 years due to its long orbital period of about 29.5 Earth years. Saturn's atmosphere is a complex, dynamic environment. Observations reveal cloud bands similar to those on Jupiter, though generally less vivid in coloration. These bands are formed by differential rotation and complex convection patterns within the planet's gaseous layers. Beneath the upper cloud decks, composed primarily of ammonia ice crystals, lie layers of ammonium hydrosulfide clouds and water clouds at greater depths. Temperatures at the cloud tops average around -178 degrees Celsius, but conditions vary significantly with depth and latitude. One of Saturn's most remarkable atmospheric features is the hexagon at its north pole. This six-sided jet stream, first observed by the Voyager spacecraft and later studied in detail by the Cassini mission, measures about 30,000 kilometers across. The precise cause of the hexagon's shape remains a topic of research, with theories involving standing waves in the atmosphere. Saturn is also home to some of the most powerful storms in the solar system. Giant storm systems, sometimes called Great White Spots, appear roughly once every Saturnian year and can last for months. Winds in Saturn's upper atmosphere can reach speeds of over 1,800 kilometers per hour, far surpassing any wind speeds on Earth. Saturn's rings are perhaps its most defining feature. While other gas giants, Jupiter, Uranus, and Neptune, also have ring systems, Saturn's are by far the most extensive and visually striking. The rings extend from about 7,000 kilometers above Saturn's equator to more than 80,000 kilometers outward, yet they are incredibly thin, only about 10 to 30 meters thick in most places. The rings are composed primarily of water ice, with smaller amounts of rocky material. They are divided into several major sections, labeled from the planet outward as D, C, B, A, F, G, and E rings, with numerous gaps and divisions such as the Cassini division between the A and B rings. The particles range in size from tiny dust grains to chunks several meters across. The origin of the rings remains uncertain. Some theories suggest they formed from the remnants of a shattered moon or comet, while others propose that they are leftover material from the planet's formation. Observations from Cassini indicate that the rings may be much younger than Saturn itself, possibly only a few 100 million years old. Saturn's moons are a diverse collection, each with unique characteristics. As of recent counts, Saturn has over 140 confirmed moons, ranging from small, irregularly shaped bodies to large worlds with complex geologies. Titan. The largest of Saturn's moons, Titan, is bigger than the planet Mercury. It has a dense atmosphere composed mostly of nitrogen, with small amounts of methane and other hydrocarbons. Titan's surface features rivers, lakes, and seas of liquid methane and ethane, as well as vast dune fields and icy plains. Beneath its icy crust, scientists suspect an ocean of liquid water mixed with ammonia, which could have implications for astrobiology. Enceladus. Enceladus is a smaller moon, only about 500 kilometers in diameter, yet it has become one of the most intriguing objects in the solar system. Cassini discovered geysers of water vapor and ice particles erupting from fractures near its south pole. These plumes contain organic molecules and hint at a subsurface ocean, making Enceladus a prime target in the search for extraterrestrial life. Other moons. Other notable moons include Rhea, a heavily cratered icy world, Iapetus, with its dark two-tone coloration, and Mimas, famous for a large impact crater resembling the Death Star from popular culture. Many of Saturn's smaller moons act as shepherds, influencing the structure of the planet's rings through gravitational interactions. The journey to understand Saturn has spanned centuries, beginning with telescopic observations in the 17th century. Galileo Galilei was the first to observe Saturn through a telescope in 1610, though he could not clearly identify the rings. Christian Huygens, in 1655, proposed the correct explanation for the rings and also discovered Titan. In the modern era, spacecraft have provided unparalleled insights. Pioneer 11 flew past Saturn in 1979, becoming the first spacecraft to visit the planet. The twin Voyager probes followed, capturing detailed images and discovering new moons and ring structures. The Cassini-Huygens mission, a collaboration between NASA, the European Space Agency, and the Italian Space Agency, arrived at Saturn in 2004 and spent 13 years studying the planet, its rings, and its moons. The Huygens probe successfully landed on Titan in 2005, providing the first direct observations of its surface. Cassini's mission ended in 2017 with a dramatic plunge into Saturn's atmosphere, a maneuver designed to prevent contamination of potentially habitable moons. Saturn has held a prominent place in both scientific study and human culture. In Roman mythology, Saturn was the god of agriculture and time, a figure derived from the Greek titan Cronus. The planet's slow movement across the sky gave rise to its association with time and cycles. In astrology, Saturn is often linked to discipline, structure, and limitation. While these associations are symbolic rather than scientific, they reflect the long-standing human tendency to connect celestial objects with meaning. Scientifically, Saturn serves as a natural laboratory for studying planetary atmospheres, magnetospheres, and satellite systems. Its magnetic field, while weaker than Jupiter's, is still substantial and influences the space environment around the planet. The interactions between Saturn's moons, rings, and magnetic field provide valuable data for comparative planetology. Future missions to Saturn are under consideration, though none are currently confirmed for the near term. NASA's Dragonfly mission, scheduled for launch in 2027, will explore Titan using a rotorcraft lander capable of traveling to multiple sites. While Dragonfly will focus on Titan specifically, its findings will contribute to our broader understanding of Saturn's system. Concepts for future missions include orbiters and landers for Enceladus to study its subsurface ocean and potential for life, as well as probes designed to sample Saturn's atmosphere directly. Continued observation from Earth-based telescopes and the James Webb Space Telescope will also refine our understanding of Saturn's rings, weather systems, and moon interactions. Saturn remains one of the most captivating objects in our solar system. Its beauty, complexity, and mystery continue to challenge scientists and inspire the public. From the icy particles in its rings to the hydrocarbon seas of Titan and the hidden ocean of Enceladus, Saturn's system is a microcosm of planetary diversity. Studying Saturn not only deepens our knowledge of this remarkable planet but also offers clues about the processes that shape planets, moons, and ring systems throughout the universe. As technology advances and new missions are launched, the next chapters in Saturn's story are certain to reveal even more about the ring giant that has fascinated humanity for centuries.